Hi, welcome back to Calculus. Today we're looking at section 9.10, binomial series. So these are actually kind of fun, and they are going to bring us back and make us think about some algebra that you probably did once upon a time. So let's look at this function, f of x equal to 1 plus x raised to the m power. This is our basic binomial series. There are definitely ways to make it more complicated, but this is going to be our basic binomial series. So I started by plugging in 0, and if you plug in 0, you get 1. And why I plugged in 0 will become apparent here in just a second. If I take its derivative, I just drop the exponent and subtract 1 from the exponent, so I get m times 1 plus x to the m minus 1. And again, if I plug in 0 to it, now I get m. Right? So if x is 0, 1 plus 0 is 1, 1 to any power is just 1. So I get m. If I take the second derivative, I drop down the m minus 1, so I get m times m minus 1 times 1 plus x to the m minus 2. But again, if I plug in 0, I just get those two exponents that got dropped down, the m and the m minus 1. And we can keep this going for as long as we wanted and use it to generate a Taylor series at x equals 0. So at x equals 0, you get 1 plus mx plus m times m minus 1 over 2 factorial, because again, Taylor series times x squared plus m times m minus 1 times m minus 2 over 3 factorial, all the way out to m times m minus 1 multiplied out to m minus k plus 1 over k factorial times x to the k, and then continuing forever. Now this is a series that will converge if the absolute value of x is less than 1. That works out by a ratio test just fine. So if you need to, you can go back and try and convince yourself of that. Anyway, converges if the absolute value of x is less than 1. So we can say then that 1 plus x to the m is equal to 1 plus the sum of k equals 1 to infinity of this thing that we're going to talk about in just a second. This is m choose k times x to the k power. So this m choose k is equal to m times m minus 1 times m minus 2 all the way out to m minus k plus 1, all over k factorial. And that's just what it is. It's a notation that we have. It really comes out of combinatorics and probabilities, and it's a button on your calculator if you can find it. So the button on a TI 83, for instance, or 84 is under the math button. If you press the math button and scroll over to where it says PRB at the top, which is for probability, you can find this symbol NCR down on the list. So to use it, you would just type in the M, and you'd hit that, and then whatever your K is, and out will pop that number. Unfortunately, that button only works if M and K are integers. In particular, the M. The K is going to be an integer for us, but M is not always going to be. But it does work if those are integers, and so you can just type it into your calculator, and that's really nice. All right, so let's do a couple of examples, and we'll talk a little bit more about binomial series. All right, so continuing on, let's find the first four terms of the binomial series for 1 plus x to the 1/3 power. Now this one's a bit annoying because of the fraction exponent. We can't use our calculators to evaluate those fun little binomial coefficients. So we know the first term is 1. The second term is just the power times x. Right? That's really, really nice here. So we get 1 plus 1/3 x. The third term will be 1/3, the exponent, times the exponent minus 1, so negative 2/3, all over 2 factorial x squared, and then we just keep subtracting 1. So 1/3 times negative 2/3 times a negative 5/3 over 3 factorial x cubed. That'll give me 4 terms. If you work through it, you're going to get 1 plus 1/3 x minus 1/9 x squared plus 5 over 81 x to the third. Be careful with those fractions and with the negative signs. Very easy to get stuff to go wrong there. And then I have this binomial series, and I have one more thing after this I want to talk about just real briefly. But I ran out of room, so we'll need another board. Find the binomial series for 1 minus x over 2 to the 4th. Now this one's a little bit different because we don't have x here. We have a minus x over 2. So turns out it works the same way. Just use negative x over 2 in place of all the x's. So this will be 1 plus the sum k equals 1 to infinity of these 4 choose k's times negative x over 2 to the k power. And so what's convenient here is after we get to k equals 4, anything past that is just 0. So we only have to go through the 4th power here. Anyway, so we get 1. 4 choose 1 is 4 times the negative x over 2 to the first, plus 4 choose 2 is 4 times 3 over 2 factorial. There's that pattern that we have going again, times negative x over 2 squared, all the way out to here we have 4, 3, 2, 1 over 4 factorial minus x over 2 to the 4th. And yes, that's just going to cancel itself out because they're the same thing. So doing the arithmetic or using your calculators, again, you do 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. We get 1 minus 2x plus 3 over 2x squared minus a half x cubed plus 1/16 x to the 4th. All right, I have one more thing, and it's really pretty slick, so hang on for just a second. All right, so one last thing that I just kind of wanted to show you here because it's really pretty cool, and it kind of takes us back to algebra a little bit, is anytime you have any binomial raised to a power. So you could go through all the annoying work of multiplying it out, but it turns out that the binomial theorem does it for us. And so basically this ends up being the sum k equals 0 to m of m choose k times a to the k times b to the m minus k, right? And so what you end up having here is you have powers that are going in different directions. In this case, the a's are going to be going up. They're going to start at 0 and go 0, 1, 2, all the way up to m. And the b's are going to work their way down from m to 0. So for instance, let's say I wanted to expand this binomial, x plus 4 to the 5th. Using this, I can write it out. It's a little annoying, but I only have to go from 0 to 5. So I start with 5 choose 0, and then my first piece, x to the 0 power, and 4 to the 5 minus 0 or 5th power. And you can see I have 5 choose 0 times those, 5 choose 1, now I have x to the first, 4 to the 4th, and I work my way all the way down to 5 choose 5, x to the 5th, 4 to the 0 power. And then at that point, it's a little bit annoying. There's a lot of arithmetic, but hopefully you're working with a calculator here. Because if you are, you can get these pretty easily. And you get just this, 1024 plus 1280x plus 640x squared plus 160x cubed plus 20x to the 4th plus x to the 5th. And so you get this lovely big answer. But there we go. And so that's just a really neat little application of the binomial expansions. So there we go. Yeah, have a wonderful day.